Now that we have our clump values applied to our proxy pieces, we can copy those clump values to our constraints and then set up the RBD clusters. Now we're going to pull in the constraints from the top of the setup, but I prefer not to draw lines all the way across our network because that can make things a bit visually confusing. So I'm just going to use an object merge to bring in those constraints. And we'll point that object merge to ... /constraints. And if you middle mouse on this constraint geometry, you can see the name is on points, and on our geometry that has that clump attribute, the name is a primitive attribute. And we're going to do an attribute copy of all those clump values based on matching by name. And in order to do that, we'll have to make sure that our name is the same attribute type on our geometry versus those constraints. So you can drop in an attribute promote, connect your proxy geometry to that, and select original class as primitive, new class as point, and then the name is just going to be our name attribute. Now the geometry that we're transferring the clump attribute from isn't all of our building geometry. We've deleted out the passive section and this hole in the middle there. So we have to make sure that whenever it doesn't match up a value by name with our constraint geometry, that we have the default set up for the constraints as well. And we'll set up this default value the same as we did at the beginning with our proxy geometry and drop in a point wrangle. And in the point wrangle, set I at clump equals -1. Then connect our constraint geometry to that. And then we can add in our attribute copy. We're going to copy from the proxies, so those will go in the right input and our constraint geometry in the left. Turn on match by attribute and set the matching attribute to name. And for the attribute name, we'll select clump from the drop-down. And just to be safe, I'll set that attribute class explicitly to points. Now it's always good to make sure your setup is working correctly as you go, so I'm going to add another visualization of those clump values on this constraint geometry. So we'll drop in a color sop and set it to random from attribute, and the attribute will be clump. And as usual, you can play around with that seed value to find something that makes it a little bit easier to see. And now that we've verified that the clump values have been copied over correctly, we can apply that to our destruction rigged asset via the RBD cluster sop. Now, like many other destruction related sops, this takes 3 inputs. The second one is for your constraints, and the first one and third are for your fractured geometry and your proxies respectively. So I'll create an object merge for the fractured geom and connect that to the first input, and another object merge for our original proxies. Point that to ... /proxies, and then we'll connect that to our RBD cluster as well. Now this RBD cluster sop has a couple different modes of operation. You can combine the pieces based on the cluster value as we saw in week 1. But in this case, we're going to use the group constraints option. And you'll see when you flip it to group constraints, this is setting up a few different groups on your constraint geometry based on the cluster values you're providing. And we'll take a closer look at what each of these groups are in a moment. But in order for this to work, we have to set this cluster attribute properly. We could have been using an attribute called cluster all along, but we've been using this attribute called clump. So we'll have to specify that as our cluster attribute. And we don't want to randomly detach pieces, so we'll turn that off. And I think that's a dangerous default, so if you want, you could right-click that and say make current value default. And with cluster noise set to preserve existing clusters, I'm not sure if that's doing anything to our cluster values. We have to test it, but just to be safe, we'll set that cluster noise to none so that we use these established cluster values explicitly as they are. Now we're working with a few different types of geometry here between our fracture proxies and constraints, and it's good to keep the information consistent across all of them. And having those clump values available on the proxies and fracture pieces as well can be extremely useful. And if we had to manually copy that data between all of them ourselves, that would be a bit annoying to maintain. But thankfully, this RBD cluster SOP does that for us. And you can middle mouse on each of these outputs. And you can see when you middle mouse on a different one, it'll tell you what that output is. And you can see all of the attributes on it. And our incoming proxies here don't have the clump attribute. Neither do the fracture pieces. But if you look at all three of our outputs, you can see that clump attribute has been copied to all of them. Now, as I've said, it's good to check our work as we go to make sure everything is working properly. So I'm going to view each of those groups that have been set up on our RBD cluster SOP. So I'll create a null off to the side and call this check constraints. Now I've set up 4 blast SOPs to isolate each of those groups that were set by our RBD cluster SOP. And this helps us to check each of those groups to make sure that it looks right and to get a better idea of what each of them contain. This cluster to cluster group will contain constraints that are connecting pieces that are in 2 different clusters. The intra-cluster group is going to be constraints that are all within one clustered value. The cluster to piece group contains constraints that connect a piece in a clump to a piece that's not part of any clump at all. And the piece to piece group contains constraints that are connecting pieces that aren't part of any of our clustered sections. And now you might be wondering why all of the pieces with a clump value of -1 are not considered part of the same cluster. And this -1 value is a reserved value that the RBD cluster SOP recognizes, and that means that those pieces won't be part of any clustering. However, if you take a look at our output by checking the spreadsheet and take a look at these clump values, you can see we don't actually have values of -1 set on our geometry anymore. It's expanded all of those -1 values to be a unique clump ID for each piece. And now that we've verified that all of our clusters are working properly, we can pack this back up with our RBD pack SOP and connect all 3 of our outputs from the RBD cluster to that RBD pack. And then we can cache this to disk with a file cache SOP, set the valid frame range to save current frame, and I'm saving this to job, caches, building RBD, and constrained fractures.bgo.sc. And you can turn on load from disk and save it. And as usual, we'll add a null for this so that we can pull it into other parts of our scene later. And I'll call it out clumped constraints.